your citizens. With Interact City, you can manage all your lighting via one dashboard. Collect and share data about operations and activities. Securely store and analyze all your data in the cloud to generate new insight. Use APIs to create new applications and services. And integrate lighting with other municipal systems and services. Interact City makes your city smarter and more livable, enhances the efficiency of your street lighting system, and improves city safety and responsiveness. But don't take our word for it. Interact City.
Yeah, so then we just touch upon a little bit about IoT network architectures. On the simple terms, we already discussed multiple times in the previous slides and things like that. So when it comes to Zigbee and Zigbee or Wi-Fi related protocols, it will be mostly based on the house and household related activities will be happening. And when it comes to Bluetooth devices, for example, cameras and gadgets, headsets and mobile gadgets of watches and Fitbits, these kind of things are mostly on the Bluetooth network, and then they connect to Wi-Fi and those connected to cellular networks and then back into cloud and cloud computing. So you have seen the same kind of architecture in the previous video as well. That is how the IoT devices are connected to the networks in the back. So smart cities, what is exactly needed for smart cities and what type of applications are needed for the smart cities? We already understood that from your previous poll also. I see the public transportation is the first one and everybody seeks in the smart cities. And then water management, power, sanitation, waste management, urban mobility. So people are moving from different parts of cities to bigger cities and these kind of things, and governance, e-governance related aspects, and the citizen participation and the more activities which are needed to make smart cities more and more smarter. So this is one simple application as well. Again, this is one of the building smart innovation building application, which is more energy efficient application, which is developed on the IPv6 network of lights. Okay, and again it has sensors, multiple sensors, which save the energy, which saves a lot of efficiency of the people, efficiency of the maintenance and administration, these kind of things. This will give you a glimpse of what is the power of IoT for us.
Philips has contributed to what currently is one of the most innovative office buildings in the world, The Edge in Amsterdam. It has been equipped with a revolutionary new lighting system that uses light differently. Philips' new lighting system is both simple and sophisticated. Every luminaire throughout the building has sensors and controls. Merged with the IT network, each light point has an individual IP address. When linked to maps of the space, each connected light provides location-based information and data on how the area around it is being used.
Philips is not only showing its leadership in LED technology, but also in the world of Internet Everything, its ability to manage a very complex environment of partners to get this to market.
Philips's innovative connected lighting system offers a host of advantages for different users of a building. In offices, facility managers no longer need to clean, cool, or heat the entire building. The lighting provides them with detailed information about the usage of the building, enabling a sustainable and cost-efficient use of resources. And imagine being able to set lighting to your preference and task. Office users can personally control the lighting in meeting rooms and above their desks, even in an open-plan office via their smartphones. So they always have the right light level to support comfort and productivity. With innovations in connected lighting from Philips, light has become a pathway for information and services, generating value for our customers and partners across the globe. Innovation and you.
So that's a simple example of IoT and the power of IoT, how it is coming today. So these are some of the glimpses of smart cities today. You might already traveled in the outer ring road of Hyderabad. Some of you maybe from Hyderabad joining in this session. This is actually a smart city, smart street lighting system, which is saving the energy at the same time. If there is any incident or something like that, it directly gives the information to police and ambulance services and these kind of things. So Raipur, you can just go through the details later on, and this is the stadium which was last year inaugurated in the Ahmedabad Sardar Vallabhbhai Patel Stadium, which is providing the different street lighting systems, and these are some of the examples of street lighting applications which today we have. Okay, so not only the lighting applications are smarter and smarter, and other areas also becoming smarter and smarter. So this is one application, already real application, which is there in the city of in the country of Indonesia. So this is actually a flood management system. So there are sensors which checks the water level of the city, the whole city, and depending upon that, it sends the notification and things like that. The people can move around the city, because the city is very close to the sea level and it is equal to the sea level. So all the time they have the water inside the city, but they have to run their work every day. So it depends on the sensors they are using it. The city will continue to run on its own, right? So, and we have another applications which are agriculture kind of applications. This is actually today we have, because I am giving only where there are problems, but you can see, you can go to Google and try out what are the different IoT applications are there today. You will see a bunch of them. I'm giving this example because we are seeing this problem today, right? So onions is one of the key topic in everyone's house today. So because there is a company which is working on this solutions, how to make this available to the farmers and to the public more efficiently, right? So for example, the onion crop came out from the farmers, and they have the warehouse. They are keeping the onions in the warehouse. This company comes and they will set up their own retrofit optimal ventilations, and it will enable the climatic conditions of that particular city or things like city and the warehouse. After that, they will install their own IoT devices into that warehouse. Once they install the IoT devices, the farmers can keep the stock of onions or any kind of crop into the warehouse. Once after this completed, there are sensors which are detecting the emitted gases from these crops. It could be onions, it could be anything else, right? So these emitting gases will be the data of these gases will be collected in the sensors, and it send it back to a system where the analytics keeps happening, and they will say the predictive analysis, and depending upon that analysis, they will say that so there is a problem started coming in these onions, and it is rotting. So some onions are are getting a problem. So you have to start looking out, removing them or selling the whole crop. So timely, they will keep sending the alarms and notifications to the farmers who are using these warehouses. And depending on that, the farmer will react to this, and they will remove the rotten onions from the whole crop, or they will try to sell the onions, the whole crop. So that depending on this, they can save 20 to 25% of the onions more better, and it could be used by the public. So this is one of the basic example of IoT, and like this we can build any type of the applications and make it more livable and more attractive and more smarter in the future. So what is going to happen in the future and the future sessions, right? So I will touch upon more in the future sessions. I will touch upon wireless networks, IoT wireless networks, more detailed about short range communications, which we discussed little bit on Zigbee and Bluetooth and LoRa, these kind of things. I'll go more detailed into the network technologies and communication technologies, and mobile application technologies, mobile communication technologies, NB-IoT, 4G and 5G, which is going to come in future, and Wi-Fi devices, Wi-Fi, and then cloud technologies, mobile cloud computing, and these kind of things, and the edge computing, and many more are there in the future sessions. So that's it from me, and thank you for listening me. It was very good audience. I enjoyed the whole session presenting to you. So if you have any questions, one or two questions, we can take it up. Otherwise, we can end.
Yes, one question is there in chat box, Sumo. For encryption, which type of algorithms in IoT?
So it is depending upon the application, the encryptions will be used. For example, for devices, for hardware devices, and the communication of sensors, if we are doing encryption, generally it will be 128-bit or 256-bit encryptions methodologies are used. Sometimes more details are required, or it is more sensitive information, then they will keep using different technologies. And end to end, if we look at it, it will be mostly on the type of 256-bit encryptions with HTTPS or something like that. Any other questions? Okay, so somebody asked about the new jobs and right,
Yes.
creating of new jobs in this sector and these kind of things. Okay, so I do not know about your background, but if you see,
He's from EC
if you see the,
department.
yeah,
He's
so
from
if you
EC.
see the complete discussion and the talk, we need this technologies is going to grow wider and wider and more because of the need of the people and need of the things. So the employment and the jobs are needed in all the aspects, right? So if you see from the manufacturing industry to the application industry, everybody needed to be there to work with the IoT devices, right? So it will be going to be a future, and it needs more technical people for the future.
So one more question is there, Somu. Can you give some brief about bandwidth requirement and power consumption in IoT?
It is depending upon the application, the bandwidth will be varying. So in one of the slides, I told about bandwidth requirements, what type of bandwidths are required, what type of specifications are required for the bandwidths, right? So if you are looking at an application which I told, for example, a geyser application in the house, right? So as soon as the geyser gets an information saying that you switch on the relay or something like that, then that means it is very very low bandwidth, right? You don't need even it will be working on the kbs, okay, even lesser than kbs it can work, okay. So so it is depending on the application, the bandwidth will be varying. For example, in the manufacturing industry, if you take, there is cloth manufacturing is happening, okay. There are sensors which will be recognizing the damage of the cloth, right? When the cloth is turning in the production unit, it will be turning with a specific data rate and specific speed, okay. In that case, you need a bigger bandwidth monitoring system, which is keep on monitoring the cloth rotation, and at the same time the damage need to be identified and informed to a person who is there very quickly. So it depending on the application, and if the application is on the streets of the um, of the cities, which is a video camera application, which is a video camera which is monitoring the people who are violating from a traffic rules, then there it's needed a high bandwidth application, because it has to process as soon as the signal goes to green, it has to process maybe 10, 20, 30, 40, 50 cars or 50 bikes at the same time. So there we need a high bandwidth application. So it is depending on the application, the data rates and the power consumptions will be used.
Okay, so two more questions are there in chat box. Applications of AIML in IoT.
Okay, so very good question. It's very elaborative question. For example, if you see the example which I told, the water level sensing device, right? So there, I know that the whole city gets a notification as soon as there is a water level is going to increase. It has to be predictive. It has to be predicted by the sensors which are very close to the sea level or which are under the sea level sometimes, and they will give quickly the information to Twitter, Facebook, and all the citizens who are living in that area, something like that. So the message also should go to very quickly. So there we need very very high power missions which are running and which need to send the information very quickly. Otherwise, it's a risk to people, and it's a risk to a threat, right? So, and the second application which I can sense is for the AI and ML, right? So today, because of the pandemic and pandemic situations, all these uh, all the, for example, the banks and the financial institutions are looking out people and to make them onboarding without the people visiting to the banks. That means the customer KYC. We talk about, if we go to a bank, first person talks about is KYC, know your customer, right? So all this KYC process need to be automated um, very easily and very quickly with the applications in the smartphones, and with the applications which is running in the background. So, so this is going to be one of the AI and ML application which I can think of immediately. And in the medical terms, right? Medical industry is a lot of applications which are through AI, ML, and using the IoT information. For example, simple example like CT scans, CT and MRI scans. Um, Thousands of people's informations are collected by the MRI and CT scans data. Those are all aggregated in a bigger data which is running in a cloud, and that information will be analyzed and predicts that predicts to a doctor saying that okay, so these people are having tumors in these places, and those could be a threat to those people, something like that. So that's where the AI, ML, and IoT are very interlinked between each other, and that's the future of our industry, I could see.
Okay, one more question is there, Sumo.
Yeah.
To form a network of IoT, did we need to follow any topologies?
Yes, definitely. Um, it's again depending on the application. For example, the lighting application which we see in the video, right? So there are two different types of topologies we follow. One is it is based on the RF, which is which is very low bandwidth, and at the same time those are unlicensed bands. I said in one of the slides what is unlicensed bands means, right? So when we look at the communication mediums, we have 2G, 3G, 4G. At the same time, we have defense, air force, and military using their own communications, and at the same time, aircrafts are using telecommunications are different bands, and we should not interfere these bands into our short range communication devices. So that means we should work on the very low frequency bands, which are unlicensed bands. Every country has its own unlicensed bands. So when you wanted to build any application which is home based applications, you have to use only the unlicensed band, and you should get a permissions from the government when you are deploying these commercially to any customers or anyone. And to communicate sensors to each other, you can use this communication medium like Zigbee or Bluetooth, and make a mesh kind of network, or make a star topology or mesh topology, and continue to build the applications on top of it.
Okay, that's all, Sumo. And very good afternoon, one and all. Once again, I hope everyone is happy with this IoT webinar. It's a very short and sweet webinar. Uh, thank you, one and all. Thanks for giving me this opportunity, and thank you, Mr. Somashekar Gupta Tatwarthi. Thank you.
Thank you.